Hello. Today we're going to take some of the vocabulary that we learned yesterday and put it into action. So today we're working on the introduction to combining like terms. And actually, we're going to spend our time today gathering the terms, and then tomorrow we'll spend more time combining the like terms. So the directions say identify like terms in each list. So, first of all, we have to remember that terms can be a number, or a term could be a variable, or a term could be a combination of a number and a variable hooked together as a product. For instance, this could be a term, it's just a variable. This is a term, it's just a number. But this is a combination, it's a product, meaning side by side is multiplying, and 3 and x are hooked together and become one term as a product. So the directions go on to say start with the terms with the highest power. Create a group of like terms on the lines below. So this is what it's going to look like. I have a series of terms. This one has an x, x squared, a number, plain x's. So let's go ahead and start like they ask us to with the numbers with the highest power. So I see that I have 6x squared. And if I look further, oh, I have another x squared term, but it has a coefficient of 2. So I'm going to write down 6x squared, and I'm going to write down 2x squared. These are both the same because of the same variable raised to the same power. So they are like terms. So I don't see any other terms that have x squared. Now I'm going to start gathering the terms that have an x. So I see 7x, I have 3x, and oh, I just have x. But yesterday we discussed that if I have a variable that doesn't have a coefficient, I can write the number 1. So this is 1x. So I'm going to gather those up on this line. I have a 7x, 3x, and 1x. Those are all like terms. So you can see I have 2 more terms left, and they're just plain numbers when we're going to refer to those as constants. This is 9. It's constantly 9. Its value is not going to change. And this is 5. It's another constant. But these 2 constants are considered like terms because they do not have a variable. They're just a number. So now let's try this with another set of a list of terms. So the directions say when 2 different variables are given, we start with the variable that comes first in the alphabet. So if I scan this, I see y, x, constant, another y, and then there's z. So alphabetically, it would go x, y, z. So let's start gathering our terms. So we're going to start alphabetically with x. So I'm going to start with terms that have an x. This has an x. This has an x. As I scan, I don't see any more x's. So the 2 terms that have x's are 5x and 9x. Those are like terms. So after x comes y. So I'm going to start gathering up anything that has a variable of y with it. I see y right here, but I'm going to put a 1 in front of it. So now I have 3y and I have 1y. Those are like terms because of the same variable raised to the same power. Alphabetically, next would come z. So I have a z here. And so z, I don't see anything else that matches it. So z is by itself. And then I'm going to move on to the constants, the numbers that are without a variable. So I have 8 and I have 4. So we've now gathered up all of our like terms. So let's look at C. As we scan this list, I see x's and constants. All right. So it appears that I don't have to work alphabetically. However, we start, as the first example said, with the highest power. So I'm going to scan this again, and I just see one term that has a power on it right here. So we're going to gather that one up. And since it's just one term, that's all I can gather up. There's no other term that has x squared. Now I'm going to move on to the terms that just have x without the square. And I see 3x and I see 9x. So these are like terms. And then we're done with all the x's. Now we're going to move on to the constants. I have a 10, 2, 8, and 6. Oh, there's a lot of terms that are just constants in this list. So that is our list of terms. So I'd like you to turn the page and I'd like you to start this on your own. So let's scan our list of terms. Okay, I only see x's, but I also see powers on those x's. So would you please gather up and tell me what term should be gathered on the first line? If you wrote 1x squared or just x squared and negative 2x squared, you are correct. Would you tell me what term should be on the second line? If you said 9x, negative 4x, and 5x, you are correct. Now let's write what should be on the third line. Negative 3, negative 1, and 7. So let's move on to E. Try this please on your own. If you recall, we're supposed to write these alphabetically when we are given different variables. So what do you think should be on the first line? 3a and negative 2a are the only terms that have a. What should be on the second line? You should have 3 terms on this line, 9b, negative 8b, and negative 3b. And now for the third line. The third line should be 2c. We've included a coefficient of 1 on the plane c, the variable c, so it's 1c, and then 4c. And finally, what should be on the last line? And to finish this off, 6 and 8. Let's move on to letter F. This is something we haven't necessarily discussed before. I see x squared, x, and x to the third. Again, the rule is that we gather up terms that have the highest power first. What should be on the first line? First line is as follows: 6x to the third power and negative 9x to the third power. Move on to the second line. Second line is as follows: negative 4x squared and negative 2x squared, or you could read it as negative 2x to the second power. And the final line is, negative 3x, 8x, and negative 5x. So tomorrow's lesson, we're going to move on to the combining of these terms, or putting these together, which I think is a fun task, and I hope you enjoy it. Thanks for listening to this lesson, and we'll see you next one.